Find the Taylor's expansion of cos x plus pi over 3 in ascending powers of x up to and including determine x cubed. Hence find an approximation for cos 65. Well, looking at the information of our question, what you can see is we're given f of x plus a is equal to cos of x plus pi over 3, and that a equals pi over 3. So we need to identify which form of Taylor series we're going to use, and the form of Taylor series that matches up to this example is the second one that I've highlighted in green here. So tailoring this to our needs, what we can say is f of x plus pi by 3 is going to be equal to f of pi by 3 plus x f dashed of pi by 3 plus x squared over 2 factorial f of double dash pi by 3. Let's just quickly, instead of putting x there, let's make sure I put pi by 3. Plus, and I'm only going up as far as the third term, so I need to then write x cubed over 3 factorial f differentiated 3 times and substitute pi by 3 in. Okay, so starting off, I have f of x. We could say, easy enough here, this is going to differentiate to give us cos x. Well, f of x is this cos x because we're just removing the a from this, should I say, sorry. So then we're saying f of pi by 3. Evaluate cos of pi by 3 and we get a half. F dashed of x, differentiate cos x, we get minus sin x. F dashed of pi by 3, substitute pi by 3 into sin x, we get minus root 3 over 2. Please make sure you work with exact answers because we're working in series, we need to be as exact as possible. F double dashed of x, differentiate minus sin x, you get minus cos x. So then f double dashed of pi by 3 is simply minus a half. And finally, differentiate f of x for a third time, differentiate minus cos x, we get plus sin x. And so when we substitute in pi by 3 into the third derivative, then we get root 3, positive root 3 over 2. So this gives us the series then, that's f of x plus pi by 3 is defined as our first term, f of pi by 3 was a half, plus x times f dashed of pi by 3, which is minus root 3 over 2, plus x squared over 2 factorial, 2 factorial evaluated as 2, multiplied by f double dashed of pi by 3, which is minus a half, and then plus x cubed over 3 factorial evaluated is 6, multiplied by a third derivative of f of x with pi by 3 substituted in, which is root 3 over 2. Now, when I work through this, f of x pi by 3 simplifies to give us a half. First term is going to be negative, so I get minus root 3 over 2 x. Second term is also going to be negative, and I get a quarter, or minus a quarter x squared. The third term is going to be positive, and I get root 3 over 12 x cubed. And that's our Taylor series expansion. Now, we're asked to evaluate cos 65. First of all, this involves calculus, so we can't just use cos 65. We need to know that cos 65 is going to be 65 pi over 180, which simplifies to give us 13 pi over 36. So essentially what we're saying, we want to evaluate f of 13 pi over 36. So what I know is x plus pi by 3 must be equal to 13 pi over 36. When I subtract the pi by 3 from both sides, the x value that I need in order to generate the right value for this approximation is going to be pi by 36. So cos 65 can be approximated by f of pi by 36 plus pi by 3. So this is the bracket, this is why we need to substitute and rearrange to find that x value. That means that I'm going to substitute pi by 36 into my expansion here, because that is my x value. The a value, remember, is pi by 3. So I get half minus root 3 over 2 pi by 36 minus a quarter pi by 36, not sure why I put half there, pi by 36 squared, and then finally plus root 3 over 12 pi by 36 cubed. Now, when you put this all into your calculator and work through it, what you should find is that this comes out as 0.42262, correct to 5 decimal places. Now, if you was to actually get your calculator and evaluate cos of 65, what you'll find is that actually our accurate answer is 0.42262 to 5 decimal places. So this approximation is correct to the nearest 100,000th, at least. Okay, I hope that all made sense and you understood my solution.